Today we move on to the geometric series, which is basically the sum of a geometric sequence, and we're going to develop a formula for the series pretty much the same way Gauss did. And again, Gauss was a little guy when he did this. Now, we remember what Gauss did when he was working with the arithmetic was he reversed the order of that arithmetic series and found out the sum was the same. He tried the same thing for the geometric, but it didn't work. So he had to come up with another trick. And his trick was this. Alright, he took and multiplied every term in the series by the ratio. So he took and said, what if I take and multiply the ratio by this sum? Well, if I multiply the ratio by the sum, then he would distribute r to each one of these terms. So it turns out that when he distributed r through, this first term became the second term. This term, second term, became the third term. So on and so forth. Until he did the multiplication on the last term, and when he multiplied this last term by r, we remember we add the powers, so that was a1 or a sub 1 times r. And now he noticed, hey, I've got a lot of the same things stacked up underneath each other, kind of like he did with the arithmetic, but he had these extra two terms, so he couldn't use the same kind of formulation as he did earlier. So here's what he did. He said, well, look, if I take and subtract all this, then anything that's alike is going to subtract out. Alright? And I have the sum of n terms minus r times the sum of n terms is equal to the first term 0, 0, 0, 0, 0, 0, but I have this last term in here that I'm subtracting out. And then he said, well, hey, I can isolate this by pulling out this sum, which leaves me with 1 minus r, and then I can factor out an a1 and have 1 minus r to the n here, and I end up with the sum equals the first term times 1 minus the ratio raised to the n power over 1 minus the ratio. And that's the formula we actually use. The sum of n terms in a geometric series is equal to the first term times 1 minus the ratio raised to the number of terms over 1 minus the ratio. So let's do a number of these problems. Sum of the first 12 geometric terms where I have my first term and my ratio of -3. And again, the sum equals the first term, 1 minus the ratio to the n power over 1 minus the ratio. So I take my first term, plug it in, there's a 4, 1 minus -3. How many terms do I have? 12 over 1 minus that ratio. And this is just a plug and chug problem. So it becomes calculator oriented, and I get a sum of -531,440. Again, we'll find the sum. Here's my first term, my last term, and my ratio. Well, again, if I just write this formula out, I have first term 1 minus my ratio to the n power over 1 minus my ratio. That's great that I have that first term. It's 48. 1 minus, I have a ratio of a half. That's good as well. But I don't have the number of terms. So I'm going to need to do that. I'll go back to my sequence equation, which says the nth term is equal to a1 multiplied by r to the n minus 1 and see if I can find it from here. I know my third term is 3, my first term is 48, and my ratio is a half to the n minus 1. Well, now I have everything but the number of terms, which is exactly what I need. So I'm going to go through. This is 1/16 is equal to a half to the n minus 1 power. I can get the same base. This is a half to the 4th is equal to a half to the n minus 1. Therefore, 4 equals n minus 1, and n equals 5. So now I can plug this in, and I have 48, 1 minus 1/2 raised to the 5th power over basically a half. And that's equal to the sum of the first 5 terms. And that gives me a total of 93. So here's our sigma notation again. Let's just verify this is a geometric series. Find the first term by plugging 1 in. I end up with 2 times -5 raised to the 0 power. We know anything to the 0 power is 1, so that's just 2. My second term is 2 times -5 raised to the first power, which is -10. My third term is 2 times -5 raised to the second power, which is 50. It appears we're multiplying by -5. So true, it is geometric. So in that geometric formula, I have first term, which is 2, 1 minus the ratio, which I know is -5. Number of terms is 12 over 1 minus that ratio. And we're going to get the sum of the first 12 terms. The answer to this is actually rather large. About -81,380,208. So in this case, we have a second term and a fifth term, and we want to know the sum of the first 7 terms. Well, again, if we know that the sum of the first 7 terms is going to be equal to the first term times 1 minus that ratio to the nth power, and n equals 7 over 1 minus a ratio, looks like I'm going to need a couple of terms here. Alright, now what I can do is I can say the following. I can say if I have a fifth term and a second term, I can use my geometric sequence formula of second term, which is -36, equals the first term, which I don't know, times a ratio, which I don't know, to the n minus 1. So that's 2 minus 1 power. Well, this is just -36 equals the first term times the ratio. Then in my next expression, I can say that I have the fifth term, which is 972, is equal to the first term times that ratio to the 4th power. This is going to be a pretty easy substitution. I think what I'll do is solve for A1 in this case. So, or actually I'll solve for R. No, I'll solve for A1. So -36 over R is equal to the first term. And then make a substitution right over here and say 972 is equal to -36 over R times R to the 4th. Well, if that's the case, R and R to the 4th reduce to R to the 3rd. So I have -36 R cubed is equal to 972. Go ahead and divide 972 by 36. that gets me a nice clean 27, which is r cubed, so r is equal to 3. And now, once we have r equal to 3, we have everything but the first term here. But that shouldn't be difficult because given the r, I can find the first term. So I know that 36 of the negative type over a ratio of r is going to equal that first term. So my first term is equal to negative 12. Easy enough to get this problem done now. Plug negative 12 in. 1 minus that ratio of 3 raised to the 7th power over 1 minus 3. And we end up with a sum of negative 13,116. So in this problem, we know our sum is 315. It's geometric because we have a ratio here. Therefore, I need my first term. 1 minus my ratio. There's 6 terms total, so I have the n value over a half. Multiplying the half to the other side, I have 315 over 2 is equal to the first term times 1 minus 1/2 to the 6th is 1/64. So that's 315 over 2 equals 63 over 64 times the first term. Therefore, 315 over 2 multiplied by 64 over 63 equals that first term, which gives me a total of 160 for my first term. Now if I have my first term and I know it's geometric, I can find my fourth term. 160 multiplied by my ratio of a half raised to the 4 minus 1 power. So this is 160. Half raised to the 3rd power is an 1/8. And therefore my fourth term is 20. And that's all we've got. Make sure you fill out that lesson summary and do your Connect Ed.